In this video lesson, we're going to look at some tension forces. So let's look at the situation. You have a 5 kilogram mass that's being supported by 2 ropes, tension rope in the 1 and tension rope in the 2. The tension 1 string is attached to the ceiling, making a 25-degree angle to the horizontal, and then tension 2 is attached to some wall, perfectly horizontal out to the right. So first thing we need to do is we need to start with a force diagram. Okay, so I'm going to draw my 5 kilogram block as a dot. I've got force gravity pulling straight down towards the earth. Force tension 1 is going to go up diagonally like that, and then force tension 2 goes out to the side. Now, force tension 2 and force gravity are both in line with the axis, but force tension 1, since it's diagonal, needs to be split. And notice how I write them. Let me write that a little bit more clearly. This is going to be force tension 1 in the y, and this is force tension 1 in the x. I need to make sure I am specific about the 1 and the number 1 to show that it's for tension 1. Now, since my 25-degree angle is here, that's also 25 degrees here as well. So in my picture, it's going to be 25 degrees right here with the horizontal. All right, what do I know? I know the block is 5 kilograms. So if I know the block's 5 kilograms, 5 times 10 gives me a force gravity of 50 newtons. Now, what is also equal to 50 newtons? Well, force gravity is going down, and force tension 1y is going up. So that also is equal to 50 newtons. So I'm going to replace that. Force tension 1 in the y direction is also 50 newtons. And what am I trying to solve for? I'm trying to solve for tension 1 and tension 2. Tension 1 is the hypotenuse of that triangle, and I know the opposite side is 50. So sine of 25 degrees is equal to opposite, which is 50 newtons, over hypotenuse, which is the force tension of the first string. If I rearrange that equation, that comes out to be force tension 1 is equal to 50 newtons divided by sine of 25 degrees. So plugging that into my calculator, 50 newtons divided by sine of 25 is going to give me my answer of approximately 118.3 newtons of tension in rope number 1. Now, rope number 2, the tension in rope number 2 is the same thing as the tension 1 in the x direction. So I need to solve for what is force tension 1 x. And once I know what that is, I can go ahead and solve for what force tension 2 is. Force tension 1x is the adjacent to 25 degrees. So at this point, you've got a couple options. I'm going to use tangent. So tangent of 25 degrees is equal to opposite, which is 50 newtons, over adjacent, which is the force tension 1x. The reason I'm using tangent and not, let's say, cosine is because if I used cosine, I'd have to use hypotenuse. And remember, the hypotenuse was rounded, so I wouldn't get an accurate answer. Versus if I use tangent, I'm using the value of 50, and that is exact. That's exact, and that's an exact answer, so that I don't have to get rounding marked off or anything like that. So if I rearrange this equation, force tension 1 in the x direction is equal to 50 newtons divided by tangent of 25 degrees. So 50 newtons divided by tangent of 25 degrees comes out to be 107.2 newtons. And since force tension 1 in the x is equal to 107.2 newtons, that also means that force tension 2 is also equal to 107.2 newtons.